In this video, I will explain what is free body diagram and what are the support reactions. So in this slide, I will explain what is free body diagram. Free body diagram is a sketch of the outline of the shape of the body which is being isolated from its surrounding. So you can see this plane uh, which whose outline shape is being plotted and it has been isolated from its surroundings. And then the forces which are acting, first one is the action force W, and then there are reaction forces which are at the support, and this plane is supported at its wheel at the surface. So these are two reaction forces are also shown in this figure. So free body diagram is that diagram in which we draw the outline of a body and then we plot all the forces which are acting on that body and also the moments. So we are now discussing 2D force system, and you can see all the forces are acting in the same plane. So this type of force system is called two-dimensional or coplanar force system. So later we will discuss three-dimensional force system, but for now our topic is for two-dimensional force system. So now we are going to discuss the support reactions. There are two types of support reactions. The first one is the support which prevents the translation of a body. So translation means the horizontal motion or vertical motion. This is called translation. And the second type of support is the rotation. Rotation can be either in clockwise direction or anti-clockwise direction. So these are the two types of motions that are found in bodies. So there are few supports which only restrict the translation, and there are few supports which only restrict the rotation, and there are also some few supports which support both types of motion. So if a support prevents only the translation of a body, then a force is developed on the body in that direction. So we only represent a force there. And if rotation is also prevented, a couple is shown on the body at the supports. These are few supports shown in this figure, and I will explain the possible reaction there. So first we will examine, this is a roller support, and we can see that this roller can restrict in its motion only in the y direction. So force in the y direction is shown here, and we can see this roller cannot restrict its motion in the x direction, and it also allows the rotation. So we cannot represent a force in x direction or rotation. We cannot represent a rotation here because it is restricting the motion only in y direction. So we have placed a force here only in y. Then we'll examine a pin connection. This is a pin point, and we can see that this beam cannot move in x or it cannot move in y. So we will now place two forces in x and y, but it can move, this beam can move in rotation. So we cannot place a couple moment on this point. So it is shown here that two forces are shown. Fx and Fy are two reaction support forces. So reactions are produced due to the action forces. So and reaction forces are always produced on the supports. Then we will examine a third type of support, which is a fixed support. So in this case, the beam is fixed at this point. It either it is welded at this point or it's cemented at this point. So now the beam cannot move in X, it cannot move in the Y. So we have placed two forces at this support. So first one is in the X, the first second one is in the Y. So secondly, it cannot rotate either in clockwise or anti-clockwise direction. So we also place a movement here as well. So this is shown in this figure. You can see here, and this is the point, support point, and there are two forces Fx and Fy shown, and also a couple moment shown. There are now three reactions at this point. Two are translational forces and one is rotational movement. So these are few practical example. uh, you can see here that this building is supported by a column which is pinpoint. This is a pinpoint, and this rocker support is supporting a bridge. This is the bridge, and this rocker support is and this is restricting the bridge movement in only y direction. So we place a single reaction here, but it allows its horizontal motion. So we cannot place a reaction force in horizontal direction. We can only place a force in y direction. This is a cable which is exerting force on the bracket. So the force in the cable is always in the direction of cable, in this direction. So force is always acting in the cable direction. And this in this figure, a concrete block is resting against a ledger, and this concrete block cannot move in y. So we place a vertical force, but it can move in the x direction, and it can also rotate in any direction, clockwise or anti-clockwise. So we place only one reaction at this point. Now in this figure there are beams which are welded at this point. All the beams are welded together. So this beam cannot move in x, it cannot move in y, and it cannot rotate in any direction. So we place three reactions at this point. So this is how we place support reactions, and now we will examine in the coming examples to understand what is a free body diagram and what are support reactions. In the first figure, we can see that a beam is fixed on the wall, and a force is acting on this beam which is 1200 Newton. Also the beam has a mass of 100 kg. So first we have to draw a outline of this beam like in this figure, and then we will show all the forces which are acting and also the reaction forces on this beam. So first force is given which is 1200 Newton is shown on this figure, and also the weight of this beam which is 100 kg multiplied by the gravitational constant. 100 into 9.8 is 981 Newton, which is also acting downward, and it is acting at the center of mass of this beam which is at G point. These are the two action forces, and the reaction forces, because it is supported at this wall, and uh, it cannot move in the x direction either, not nor it can move in the y direction. Also its rotation is also restricted, so there will be three reaction forces. You can see here its AY reaction is given in the upward direction. It is given upward because the action forces are downward, so reaction force will be on the upward direction, and moment reaction moment is given in the anti-clockwise direction because the moment produced by the action forces is in the clockwise direction, so its reaction will be in the anti-clockwise direction. And lastly, the AX reaction is given in the x direction. In the second example, which is a brake lever of automobile, in this example, draw the free body diagram of the foot lever shown in figure. The operator applies a vertical force to the pedal so that the spring is stretched 1.5 inch and the force on the link B is 20 pounds. So first we need to draw a free sketch of this lever, like shown in here. We have isolated this lever from the whole system, and then we will show all the forces which are acting on this lever. You can see here that this lever is supported at point A, which is, you can see here, is a pin support. So pin support is basically preventing the motion in X and Y, but it is allowing the rotation of this link. So now we will draw the action forces first. So first we will draw first force, which is F in the downward direction, and this is a link, or we can say a string, a link. uh, in the force in this link will be in the direction of this link, like in the case of rope or string explained in the previous slide. So force direction is in the direction of link, but its magnitude is also given, which is 20 pounds, so we have shown it here. The second force is a spring force, and its displacement is given, 1.5 inch is given, and its uh, spring constant is also given as 20 pounds per inch. So spring force, we all know that it is equal to F is equal to F is equal to Kx. So X is given as 1.5 and K is given as 20. 20 multiplied by 1.5 is equal to 30 pounds. So we are given here 30 pounds, which is a spring force. Again, it is in the direction of spring. The direction of this force is in the direction of spring. Now we have applied all the forces, and now we'll look at the reaction forces. As the force F is in the vertical direction, its reaction will be in the upward direction. So AY is in the upward direction. Secondly, the forces link force and spring force is in on the right side, so its reaction will be on the left side. So this is how we draw a free body diagram, in which this process is to first isolate the body from the surroundings and draw its free sketch. Then we will apply the action forces, and then we will draw the reaction forces. Thank you.